In this problem, we are asked to construct a back-to-back stem and leaf plot to compare the distribution of miles for female runners and male runners. We will notice that we have the data points ordered from least to greatest. In order to create a stem plot, we have to define the stem and the leaf. We might recall that a stem and leaf plot works well with a small number of values, and we can actually see the individual data points. So in this stem plot, we are going to define our stem and our leaf. Our stem is typically the larger place value, whereas the leaf is a smaller place value. For example, in our data, we can see that we have the ones place value as well as the tenths place value. Therefore, in our case, the stem is going to be the ones and my leaf is going to be the tenths. For example, our first data point, 2.8 miles, can be represented in our stem and leaf plot as our stem of 2 and our leaf of 8. Therefore, our key for our stem and leaf plot would be that 2, 8, where 2 is the stem and 8 is a leaf, is equal to 2.8 miles. We would continue to write this data in our stem and leaf plot. Taking the next value of the female runners as 2.9, we would see that it still has a stem of 2, but a leaf of 9. Our third data point is also 2.9, which would give us a stem of 2 and a leaf of 9. Our next data values have the ones place value of 3, 4, and 6. Therefore, we would write on our stems 3, 4, 5, and 6. We would include the value of a stem of 5 just so that we can see the distribution of our data. The value of 3.0 miles could be represented in our stem as 3, 0. We would continue on this process until we got to the data value of 6.3, which would be represented in our stem and leaf plot as 6, 3. If we want to create a back-to-back stem and leaf plot, we could split our table into two leaves, where the right leaf would represent females and the left leaf would represent males. Again, our stem represents the ones digit, therefore our leaf for our males would also represent the tenths. The data point 2.7 could be represented on our stem plot as a stem of 2 and a leaf of 7. We would continue on this process, plotting all 14 data values for both female and male runners. This is shown in our stem and leaf plot below. Again, our key says 2-7 is equal to 2.7 miles. We can see that we have the 14 data points for females and the 14 data points for males. We are now asked to compare the distribution of both males and females. A stem and leaf plot is like a histogram, but it has been rotated 90 degrees. If we were going to look at the distribution of our female runners, we could sketch a curve, noticing that the distribution of females looks like it's right skewed. That is, if I rotate my distribution around, I would see that I have an extreme value of 63, pulling my tail to the right, giving me that right skewed distribution. If I look at my distribution of males, I would see that this distribution looks symmetric or looks normal.